Okay, for this video, I just wanted to do an example question from the workbook. So let's actually make this graph a little bit bigger so we can clearly see what I'll end up graphing here. So I'm going to do number, and I'll use green for this. I'll do number 8 from the workbook homework. So I think it just asks you to graph the equation and to find the slope and y-intercept. So let's look at the line that they give us. It's just y equals x plus 1. What I'm going to do first is I'm going to look for the slope. So and then I'm going to find the y-intercept, and I'll try to keep these color coded and organized. So I'll look for the slope in black here. So what is the slope according to this equation? Well, the slope is really just the coefficient in front of your x term. So here, the coefficient is not explicitly written, and if it's not explicitly written, it really means it's just 1. So this is the slope. So I can say the slope, or I can call that the m value, or I can call that the rise over run. All the same thing. It's just 1. And you'll maybe find actually that it's useful to write the slope as a fraction. So I'm going to write this slope as 1 over 1. Hopefully you see it as convincing that 1 can be represented as 1 over 1. It's really the same number. And it's useful to think about slopes as fractions, as we'll see. Now let's look at identifying the y-intercept. So to identify the y-intercept, that's really just a parameter that's controlled by this constant right here. So this is our constant that we are adding to our x term. And so this is really just the y-intercept. And you could say the y-intercept is 1, or you could say the actual coordinates of the y-intercept. Because the y-intercept always lies along the y-axis, the x value is always going to be 0, and the y value is just going to be 1, that value right there. So the y-intercept there is 1, and using these two pieces of information, let's maybe look for a new color here. Or I can just use, have I used all my 4 colors? Yeah, I have. I'll use green. Okay, so to graph this, I will graph it in green. And I'm just going to graph it by using the y-intercept value and by using the rise over run, or the slope. I'm not going to do a single calculation. So if you notice here, I've not done a single calculation. I have just identified the slope here, and I have identified the y-intercept here. And so my method is first to plot the y-intercept as a point on this graph. The y-intercept should be at 0 and 1, so there we are. I could label that point, although I don't really have to, as long as I am clear about my scale. Let's say that this represents 4 units. So every step represents a jump of 1. 1, 2, 3, 4. And let's say this represents 4 units. So every step represents a step of 1 unit up for the y-axis and for the x-axis correspondingly. So after you plot the y-intercept, to plot some other point, you can use the slope. So use the slope to plot one other point. And that's all you really need to do. So here we know our rise over run is 1 over 1. Another way to say this is I have a positive 1 up here, so my rise is going to be upwards, not downwards. And I have a positive number on my denominator, so my run is going to be rightwards, not leftwards. So starting at this y-intercept, I am going to go to a rise of 1 and a run of 1 to plot my next point. So here I went up by 1, and then I went to the right by 1 from a point that I already knew. And now we see that we have the point 1 and 2. You could keep, this is totally fine. You only need these 2 points to graph the line. Then you could just graph that line, right, and draw arrows on either end of it. So this is all you need to do. But just so you know, you could keep using the slope to plot more points, right? If the slope is if the slope is 1 over 1, then again, we could go up by 1 and to the right by 1 to plot some other point. And then up by 1 and then to the right by 1 to plot some other point, and then so on and so forth. And then we can see that whatever line we would draw ultimately crosses all of these points that using the slope, continuing with the slope, we would get those points anyways, but we don't need to. We can just draw a straight line through these 2 points, and whatever straight line we draw through these 2 points would ultimately hit any other point that the slope would give us anyways. So this is how you can successfully graph a line, by using the y-intercept first, and then after you have this one point, you can then use the slope to find your next point, and the point after that if you like, and the point after that if you like. And then you draw a line through those 2 points, or those 3 points, or those 4 points, or however many points you would like. And that's how you can graph a line. Now, that is one way to do it. And that's actually the way I would suggest that you do it. But you could also graph this line in an alternative way. So to graph this line in an alternative way, I'll just erase this line. So to graph this line in an alternative way, I'll call this the alternate method. There's a few different methods, but here's another popular one. An alternate method is just to have a table of values, and to plug points in not to plug points in, to plug values of x in, and to see what values of y pop out when you have a certain value of x. So let's look at our equation. Our equation is, and I'm just going to move this actually. I'm going to move this just so that we don't confuse those 2 methods. And I'll redraw those circles around those numbers. Okay, and let's do our new method here. And I'll move this actually as well. So let's give ourselves some more workspace here, because we don't want to make our job even more difficult by having a workspace that is too cramped. Okay, so the alternate method here, we have our equation, y equals x plus 1. Let's plug in a certain value of x, let's say 0, because that's a really nice easy value to plug in. And then let's see what the value of y must be when x is 0. So y equals 0 plus 1. That will give us y equals 1. So when we plug 0 in for x, we get 1 for y. That's an ordered pair right there. That's one ordered pair. We can do this again if we like. We can plug in some other value of x. So let's plug in some other value of x. What's a nice value of x that we could plug in? I don't know, 3. Let's plug in 3. I don't know why I chose 3, but let's do it anyways. So for my equation y equals x plus 1, if I'm plugging in the specific value of 3 for x, this is what my equation will look like. Y equals 3 plus 1. So when x is 3, what must y be? Well, 3 plus 1, which is 4. So when x is 3, y is 4. That's another ordered pair there. I think your workbook usually wants you to plug in 3 to find 3 ordered pairs, but 2 is good enough. 2 is honestly good enough. So let's plot these ordered pairs. When x is 0, y is 1. That's actually the y-intercept that we found just by looking at the equation before. And then when x is 3, y is 4. So when x is 1, 2, 3, y is 1, 2, 3, 4. So that's our other point there. And we can connect these 2 points in a line. And this is really the same line that we had before. This is the same line that we had before. It's just that we got the line through an alternative method where we plugged in specific x values to see what specific y values would correspond to them. So there you have it. There are 2 different methods to graphing a line. One which involves absolutely no calculations at all, right? You just look at the equation, what is the y-intercept and what is the slope. Plot the y-intercept as your first point, use the slope to find some other point. And this alternative method where you plug numbers in for x and you get numbers out for y, and then you just keep track of those ordered pairs and you can plot them. You can plot them on your graph and then connect those points together in a straight line. So hopefully that's helpful for questions like number 8. Either of these methods is acceptable.